Sri Sai Ram. Dear children, I welcome you all to this class. Last class we have discussed about carbon and its forms. Today's class we are going to discuss about the versatile nature of carbon. Before that, let us look at last class assignment solutions. Draw electron dot structure for F2 molecule and H2S. Let us look at F2 molecule. First, F2 molecule is made up of two fluorine atoms that you have to remember. First, you have to write the electronic configuration of fluorine, that is atomic number 9. Its electronic configuration is 1s2, 2s2, 2p5. How many valency? 1. How many valence electrons? There are 7 valence electrons. Now, fluorine atom, how many? 7. These two share one electron together to form a bond, that is covalent bond, to form F2 molecule. Each fluorine atom shares one electron to form a single bond, single covalent bond, that is the F2 molecule. This can also be written like this is the structure. Next, for H2S, hydrogen atomic number 1 electronic configuration is 1s1, sulfur electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p4, atomic number is 6. Then you can easily write the structures. This is the electron dot structure for H2S. Next, bond there. This is the H2S structure. Next question, very important question. Why does carbon not exist as C4 minus anion, C4 plus cation? We have already discussed in last class. Let us quickly recap this very important concept. Carbon would gain 4 electrons forming C4 minus anion. Anion means gain, that is C4 minus means gaining of electrons, that is 4 electrons. But it would be difficult for nucleus with 6 protons to hold on to 10 electrons. For nucleus it would be very difficult. For example, I gave an example. If I have a capacity to have 2 idlis, if some others force me to have 4 more idlis, it would be very difficult for my stomach to digest. Similarly, in the case of C4 minus anion, it would be very difficult for nucleus to hold on 10 electrons, that is extra 4 electrons. So, this anion will be unstable. That C4 minus anion would not exist. Similarly, in the case of C4 plus cation, to lose electrons, it requires large amount of energy. And to remove 4 electrons, leaving behind a cation with 6 protons in its nucleus holding on to just 2 electrons, a large amount of energy is required. So, this C4 plus cation would not exist. Similarly, what we have understood, C4 minus and C4 plus would not exist in carbon. Next, why do covalent compounds not conduct electricity? Very simple. Covalent compounds not conduct electricity because, very important, they do not have charged particles. Ionic compounds conduct electricity because they have charged particles. Here, covalent do not have charged particles, so they do not conduct electricity. Next, write any 4 differences between diamond and graphite. We have already studied. In allotropes, there are 2 forms, one is crystalline and another one is amorphous. In crystalline, we have studied about diamond and graphite. These are the differences between diamond and graphite. Please look at this slide. Next, today's class we are going to discuss about very most important properties, that is catenation, very important, very unique property of carbon. Next, tetravalency of carbon or action of tetravalency, that is the tetravalency of carbon, very important topic, and also isomers. These 3 are very unique property of carbon that we are going to discuss today. Before that, let us look at the definition of catenation. What is catenation? See here, unique ability, very important, the unique property of carbon to form bonds with other atom of carbon, giving rise large molecules. very important, unique property of carbon to form bonds with other atom of carbon, giving rise bonds, large molecules, is called catenation. One more definition, the links developed by carbon atom, links like this, links developed by the carbon atoms, this is the links developed by the carbon atoms to form long chain of molecules is also referred as catenation. See, this is the link developed by the carbon atom to form long chain molecules. To form long chain of molecules is also referred as catenation. This is the definition of catenation. Next, catenation is also involved in the formation of allotropes of carbon. We know what are allotropes of carbon. This catenation property is also involved in allotropes of carbon. Based on their links, we have based on their links, it has divided into three types. One is straight chain. If it is straight chain, the links developed if between the two between the carbon atoms, if the links developed are in straight chain, then it forms straight chain. This is the one of the type, that is straight chain. Second is branched, links may be developed in a branched way. Third type is maybe in a cyclic way. Types of catenations, remember what is catenation, and based on their links they are divided into three types. One is straight chain, one is branch, one more is closed chain. Next, what are saturated compounds? Very important, children. Please note down the definition. Compounds of carbon in which carbon atoms are linked to each other only by single bonds, means between the two carbon atoms, if they are linked by single bond, then they are called as saturated compounds. Remember, saturated means between the carbon atoms, any two carbon atoms or between the carbon atoms, if they are linked by a single covalent bond, then they are called as saturated compounds. Saturated means single covalent bond between the two carbon atoms, they are linked with single covalent bond. Next, they are relatively stable or less reactive compound. They are chemically less reactive or less stable compounds compared to unsaturated compounds. Example is all alkanes are examples for saturated compounds. The example is butane. You have to remember, saturated means between the two carbon atoms single bond. This is the example for saturated compounds. All alkanes are examples for all alkanes are examples that ethane, methane, butane, pentane, all these are examples for saturated compounds. Let us look at what are unsaturated compounds. Let us look at the definition, very important. Compounds of carbon having double or triple bond between the carbon atoms are called unsaturated compounds. It may be double bonds or also it may be triple bonds. Once again I am explaining, please see here. Compounds of carbon having double or triple bonds between the carbon atoms are called unsaturated compounds. If they are double bond, they are called as alkenes. If they are triple bonds between the carbon atoms, if there is triple bond, then they are called as alkynes. This alkane, alkene and alkynes we are going to discuss in next class. But before that, you have to know the basics, that is saturated compounds and unsaturated compounds are the basics for alkanes, alkenes and alkynes. Next, they are more reactive than saturated compounds, means they are more reactive. Examples, this is double bond, this is alkenes. All alkenes and all alkynes are the examples for unsaturated carbon compounds. These are examples. If you have to remember this point, the unsaturated means double or triple bonds between the two carbon atoms, you have to remember. This is very interesting and very important. This is about saturated and unsaturated carbon compounds. Let us look at tetravalency of carbon. Very important. Carbon has, first you have to write the atomic number 6, electronic configuration 1s2, 2s2, 2p, 2. There are 4 valency. Carbon has valency of 4. Next, very important, it is capable of bonding with 4 other atoms of carbon or atoms of same other monovalent elements. Means it is capable of bonding with other elements, other atoms, sorry. It is capable of bonding with 4 other atoms of carbon or atoms of same other monovalent elements. Next, compounds of carbon are formed with oxygen, hydrogen, nitrogen, sulfur, chlorine and other many other elements. Means very important points here. Compounds of carbon are formed, maybe they are formed with oxygen, hydrogen, nitrogen, sulfur, chlorine and many other elements also. Next, the properties of such compounds depends on elements other than carbon present in them. Means these are depends on their elements. The properties of such compounds depends on the elements other than carbon present in them. Let us look at the electronic configuration of carbon. Atomic number 6, atomic mass is 12, we know this. This is very important. There are 4 valence, their outermost orbit have 4, 1s2, 2s2, 2p, 4, there are 4, and inside the nucleus they have 6 protons and 6 neutrons inside the nucleus, very small nucleus. Inside the nucleus it has 6 protons and 6 neutrons. This is the electronic configuration. The valence electrons is 4 and valency is also 4. Next, let us look at the tetravalency action example. Let us look at the example how this tetravalency action happens. Let us look at the example. This you have to know, very important. Once again, there are 4, see, there are 4 outermost orbit or electrons, and inside that you know K shell, L shell, M, N, that is the, if you know that, it is easy to fill this. Next, let us look at the tetravalency in action. This is the carbon atom plus this is the hydrogen atom. This is the carbon atom we already studied. This is the hydrogen atom. Each hydrogen atom bonds with these 4 electrons to form this. See, each hydrogen atom bonds with this. See, these 2 bonds here. This bonds with this bonds with this, and this bond with this to form this molecule. This molecule is nothing but methane molecule. These hydrogen atoms combines with 4 electrons of carbon to form methane molecule. This is the tetravalency in action. Example, that is, we have taken example methane and you have understood this. This is the structure of methane. Methane contains how many covalent bonds? 1, 2, 3, 4. Covalent bond means sharing of electrons, very important. Covalent bond means both have to share their electrons, both atoms have to share their electrons. So, how many covalent bonds are present in methane molecule? There are 4 covalent bonds, 4 single covalent bonds are present in methane molecule. Let us look at last topic, that is isomers. Very interesting, very easy topic, children. What are isomers? Isomerism. What is isomerism? Let us look at what is isomerism. Isomerism refers to the phenomenon in which organic compounds have same molecular formula with different chemical structures. Means they have same molecular formula but they are different in their chemical structures. This is nothing but, this is called as isomerism. What is isomerism? Same molecular formula that organic compounds having same molecular formula but differ in their chemical structures. Isomerism increases the number of organic compounds. This increases the number of organic compounds. Isomers differ in their chemical and physical properties. Very important point. They are differ in their chemical and as well as physical properties. We have two or more different arrangements of carbon atoms only with hydrocarbons having 4 or more other carbon atoms. Let us look at the types of isomerism. First is structural isomerism and stereoisomerism. For 10th class we have structural isomerism, and stereoisomerisms we are going to discuss in higher classes. For 10th we will discuss only about structural isomerism. This is very important. This point is very important. You have to note. We have two or more different arrangements of carbon atoms only with hydrocarbon having 4 or more carbon atoms. Means 4 or more carbon atoms. Very important. 4 or more carbon atoms will undergo structural isomerism. Means I will undergo isomerism. This is very important. Let us look at what is structural isomerism. Compounds having identical molecular formula means same molecular formula but different structures. The structures may be different. Let us look at example butane. This is the example for butane. 1, 2, 3, 4. This is the butane structure. How many carbon atoms? 1, 2, 3, 4 carbon atoms. How many hydrogen atoms? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogen atoms. This is the straight. First for structural isomerism there will be two. One is straight chain, another may be branch. This is the example for isobutane. See, same carbon atoms and also same hydrogen atoms, but they are differ in their structures. This is the linear structure, this is the branched structure. Means for your reference, what is structural isomerism? You have to know having identical molecular formula, same carbon atoms, same hydrogen atoms in both same carbon atoms and same hydrogen atoms, but they differ in their structures. One is straight chain, one is branched chain. This is the 3D structure for butane. Let us draw structural isomers of pentane. Pentane means the root word pent means 5 carbon atoms. Let us draw first, right? Straight chain. This is straight chain. 1, 2, 3, 4, 5 carbon atoms and hydrogen atoms. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Carbon atoms are 5, hydrogen atoms are 12. This is the one of the structure, one of the isomers of pentane. Let us write one more isomer of pentane. This is first structure. This is second structure. Count how many carbon atoms. Count here how many carbon atoms. 1, 2, 3, 4, 5 carbon atoms. hydrogen atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogen atoms. This is the structure, that is branched chain. You have understood what are structural isomerisms. First you have to write chain, first you have to write straight chain, second you have to write branched chain. This is the structural isomerism. You can practice this in your home, and also you can practice structural isomerisms for hexane also. You can draw the isomers for hexane in your homework. Next, what are covalent bonds? Bond formed by the carbon atom, catenation property of carbon. Why carbon does not make 4 bonds with carbon atoms easily? This you can watch these videos and you can revise this concept. Next, for today's class we have learnt about very important 3 unique properties, that is, one is catenation property, second one is tetravalency, action of tetravalency of carbon. Next, isomers. These are very important. Because of these unique properties, many carbon and compounds have been identified because of the catenation property and also because of their isomers. First, to recap, let us look at the assignments. Write the differences between saturated and unsaturated compounds. We have already discussed what are saturated, what are unsaturated compounds. Very easy. You can write the differences and give 2 examples. Next, how many structural isomers can be drawn for butane? For butane we have already know what are structural isomers. Let us quickly recap. Yes, structural isomers nothing but same molecular formula but differ in their structures. We have already drawn this butane molecule. Please revise these topics and define catenation property. For today's class, we will conclude this, children, but you have to do these assignments and you have to send your assignments properly. For today's class, we will conclude. Thank you very much. Sai Ram.